Good evening. My name is David Barnes. I'm with the Planning and Building Department. Can you hear me okay? Yeah?
Sort of.
Okay. Thank you for coming tonight to our presentation of Kirkland's geology and to present our updated geologically hazardous area maps and kind of discuss the code amendment process that the city is going to go through. So tonight's agenda really quick. We're going to review the code amendment process. That's the process by which we amend the zoning code, in this case regulating geologically hazardous areas. We're also going to have a sneak peek from the Office of Emergency Management about what the city's doing there. Then we're going to have the presentation. It'll be a riveting presentation. I've seen it once before, and it's very fascinating and just really interesting. So I'm really excited for you to see that. And then after that, we've set up a microphone over here for a question and answer period, and hopefully we can answer your questions. And if we can't answer your questions, then we're going to record them so that we can get them answered, but hopefully we can answer mostly all of your questions tonight. And then I think you've already kind of looked at some of the maps that we're going to be uploading soon on our webpage. There will be a time period after the Q&A to be able to ask some questions. We've got 3 different stations to talk to either staff or the geologist about some of the things that we're seeing on the maps. So I'm up first. The code amendment process. We just got done with about a year mapping project, and those are the maps you're looking at right now. They're informing the process by which we're going to amend the code. Tonight we're kicking off via this presentation the code amendment process and showing you these maps and what they mean and how we got to get such sophisticated maps. So I'm working with AESI. They're a local Associated Earth Science Incorporated for technical expertise, because I'm not a technical expert on geotechnical matters, but I take the code amendment process through, but AESI will inform me. They have produced a report on best available science, and they've produced a report on gaps that we may have in our code right now, and they are going to be working with me, the Planning Commission, Houghton Community Council, helping the decision makers understand what we need to do and what gaps we might have in our code to make it better. So far we have 2 study sessions set up. January 11th, 2018, you're all welcome to come and attend that. There's not a Q&A for that, but you can watch the code amendment process as it's happening. Then we're going to have a second study session in February 2018, date to be determined. And then we will have a joint hearing with the Planning Commission and the Houghton Community Council. And that is an opportunity for you all, if you have not asked questions previous or made comments on the actual code amendment process, you would be able to come to a hearing and actually make comment at that hearing itself. And if things go well and we get through the code amendment process smoothly, hopefully in April and May of 2018, we would be bringing a recommendation to the City Council for adoption. So at this point, I'd like to have Heather Kelly from the Office of Emergency Management talk about how they intersect and interact with this process.
So we're very aware, good evening everybody, welcome, that anytime we put out new information about risks to you, your family, your community, it causes a lot of questions. So what we're going to be doing is, as these maps become available online, as some of the information that we are talking about tonight becomes available, we put it online, we're going to be updating our Office of Emergency Management webpage. And it's going to have links to all this information. It's kind of a one-stop shop for you. It'll be a view here, click here kind of approach to that. It'll also offer some different resources. We're going to be, I have a few that I'll put in the back of the room here for you to grab as you go out, but we found some resources on guides and information on preparedness and things that you can do or you should be aware of related to landslides and homeowners. So we're going to put those links on there as well. Again, trying to reinforce for you that there's kind of a one-stop shop for you to find information about what is these maps, what does this risk mean to you, and what could you be doing to prepare or work through that on the front end of that.
And I forgot to mention that we, in the next few weeks, will have on our planning webpage more information about this process. The maps that you're looking at will be viewable in the next few weeks. We're also going to have the link to the video of this presentation in case you want to share it or tell other people about it. So now we've come to the presentation part that I'm really excited about. We have Kathy Troost from the University of Washington, whose work, we were lucky to get Kathy. She worked on our mapping project a few years ago when we annexed, and we're lucky to get her back to work on this project again and use the best available science, latest technology to produce these maps. And I think you're going to be pretty well informed about what's going on, not only in Kirkland, but geology in general. So anyway, without any further ado, I'd like to welcome Kathy Troost. All right, this is on. It's on.
Good evening. Can you hear me okay? Good. There's one in every crowd, right? So thank you all for coming out tonight to hear about something that I feel very passionate about, and that is geology. And you are all fortunate to live in one of the most fascinating geologically active areas in the whole world, actually. So you'll hear a little about that tonight. But this was a team effort, and 4 of the team members are sitting here today, so they're going to stand up. Yes, so thank you for working so hard over the last year and a half to help put these products together. Okay, so I have a roadmap that we're going to follow, and first we're going to talk a little bit about the geologic and tectonic setting of this area, kind of a little geology 101. Then I'll tell you more about the geologic history of Kirkland, and then finally about the actual mapping project that we did. And those are the products that you see around the room and that you'll have available online very shortly. In short, we put together a database, put together a new geologic map, compiled groundwater data, looked at infiltration potential, did landslide inventory and modeling efforts, looked at seismic hazards, and some other hazards. So you may want to know why we're doing this. Actually, the fact that you're here tonight, you probably know why this is important, right? So, but if you haven't thought about it before, the geologic setting that we find ourselves in has a lot of implications for things like zoning and building codes, foundation designs for your structures, surface water management, etc. And that's why we became involved in this project on behalf of the city of Kirkland. Kirkland is a very proactive city, and they are way ahead of the game with respect to looking into what are the hazards that affect the population here, and how can the city help better prepare, as well as accommodate their own development and codes. So here's a little bit of a primer for you. So the Earth is made up of these tectonic plates, and we are in one called the North American Plate up there, and off our coast is a subduction zone where one plate is subducting underneath another plate. And that's a really significant factor for us here because it sets us up for several earthquake sources, and I'll talk about that a little bit more. The other thing that is implied, or the other factor that we have to think about, because we're on the edge of a tectonic plate, is that we also have a lot of sources for volcanoes. You may have heard of the Pacific Ring of Fire. So that's basically a ring that surrounds the Pacific plate, and just landward of that plate, we find a lot of volcanoes. Mount Rainier, Mount St. Helens, Baker, etc. What's interesting is, as that oceanic plate subducts underneath the continental plate, it gets deeper to the core, it gets hotter down there, and it melts. And when that subducting plate melts, we have magma rising, and that's what forms of our volcanoes. So one of the things that scientists have learned about this region over the last, say, 25 years is that the Puget Lowland that we live in here is getting squeezed. The plates, because of the plate motion, California really is moving north to Alaska and off the coast of western Washington. So that's putting a northward push on us living in this area. And then we have this subducting plate here, which is putting an eastward push. And what that does is sets up this rotation. And so we are stuck here in the middle between these active blocks that are pushing north. Canada, this very stubborn buttress, it's not moving. We're getting squished in the middle, right? And what's interesting about that is we are getting squeezed to the tune of about 1/4 of an inch a year. That's not a lot when you think about how quickly your hair grows or your nails, but from a geologic standpoint, that's very active. And that's why we have so much potential for earthquakes in this area. So let's talk a little bit about our earthquake sources. We have 3 sources of earthquakes in this area. I already mentioned the subduction zone. And when you hear someone talk about the big one, that's what they're talking about, an earthquake that would occur along the Cascadia subduction zone. Those can be magnitude 9, and they recur something like every 300 to 600 years. And the last one was in 1700. And I know there's a woman in the audience who survived one of these large magnitude 9 earthquakes up in Alaska along the subduction zone up there. If you get a chance to talk to her, it's fascinating. The other source is what we call deep earthquakes or intraplate earthquakes. And those are happening where the slabs are rubbing past each other at depth. So how many of you experienced the Nisqually earthquake in 2001? And did it scare you? Yeah. And that was nothing, right? I don't mean to be an alarmist, but that was a deep earthquake, and it was a magnitude 6.8, so a sizable earthquake. But because it was so deep, the amount of shaking that we experienced here at the ground surface wasn't that great, okay? The other source of earthquakes, which to me is the big one, is those earthquakes that can happen along shallow faults. And the last one that we know about was about 1,100 years ago on something called the Seattle Fault. Okay, so I mentioned that we are getting squeezed here. So we're getting squeezed here in the Puget Lowland. And what that does is it folds the bedrock layers into upfolds and downfolds. And when the rock can no longer fold, it actually breaks along a fault, right? And the Seattle Fault is one of those types of faults. And there are actually several that cross the Puget Lowland. The one closest to us here in Kirkland is called the Southern Whidbey Island Fault Zone. And I have it depicted here. Whoops. So it's labeled SWIFT, Southern Whidbey Island Fault Zone. Here's the Seattle fault zone. And what's interesting about our fault zones, unlike the San Andreas, is these faults have a lot of strands, a lot of different offsets within a several mile zone. The San Andreas, you can go out and put your foot on it, but we can't do that here. We can go out and we can find certain strands, but we can't find all of the strands, and that makes it very difficult to regulate, if you will, for building in areas where these faults exist. So this is a cross section, like a slice of cake, and it's going down to about 6 miles deep into the ground. The south side is on the left and the north side is on your right, and what you see is one of those down folds in the bedrock, and the different colors are different layers in the ground. And it shows here this downfold, and then the rocks simply could not deform anymore, and they ruptured along a fault zone. And you can see also in this image there are several fault lines. And this is kind of a cartoon of what those fault zones look like. The Southern Whidbey Island Fault Zone and the Seattle Fault Zone. Recently meaning in like the last 20 years, geologists got a new tool. It was like getting a pair of glasses for the first time in your lives, and we were able to actually see the shape of the ground way better than ever before. And that new tool is called LiDAR. Okay, it's basically airborne laser topographic mapping. And the image on the left is from Bainbridge Island. They were the first to have this new topography technique used. And it essentially allows you to see between the leaves. We call it seeing through the trees, but we can't really see through the trees. But it allows us to see the ground surface. And so on the right is what we used to be able to see. On the left is what we can see now with this new topographic tool. It's amazing. And as soon as this image appeared for Bainbridge Island, geologists are scratching their heads. What is this sharp line that we see? And the first question is, oh, it's a road. Oh, it's a transmission line. It had to be something, right? But in fact, it turns out it was an offset on the Seattle Fault that moved 1,100 years ago. And when it did move, it caused a tsunami in Puget Sound. And that tsunami traveled north, and there was an offset in the floor of Puget Sound, which is why there was a tsunami wave. And the total amount of offset between the north and the south side of this part of the Seattle Fault Zone was something like 24 feet. So pretty significant offset in ground surface. So once that was discovered, then a renewed effort began to look for other faults in the Puget Lowland. So 20 years ago, we knew of about 1. Now we know of about 20. So it's something that's changing all the time, and researchers are active searching for evidence of not only faults, but also trying to figure out how frequently do they move. Okay, so that's sort of your primer on tectonics. Now I want to give you a primer on glaciation, which is the story that I really enjoy. So we're here in the Puget Lowland, and this area has been glaciated at least a dozen times during the Ice Age, during the Pleistocene. And each time the glaciers advanced from the north, from British Columbia, and advanced down into the Puget Lowland to just south of Olympia. Some were smaller, some were bigger, but roughly to the extent that you see on this image. What that has done is given us a really beautiful setting to live in, and some incredibly scenic hillsides, and also quite a few geologic hazards, in addition to those tectonic ones that I already mentioned. And so this is the cartoon for thinking about the big picture out here in the Puget Lowland. We have a big hole between the mountains. We're sitting in this basin between the Cascades and the Olympics. And that sets up sort of the first order topographic feature that we that we work with. The next thing is something called an outwash plain. So next time you are riding a ferry or driving up or down the freeway, look out across the landscape. And one of the things you'll notice is that the tops of all the major hills all come to the same elevation. And I'll tell you why in a few minutes. Then the next thing that we see in the Puget Lowland are these deep troughs, like Lake Washington, Lake Sammamish, Puget Sound, Hood Canal. Those are all deep troughs, and they exist because this area was glaciated. And then lastly, these red squiggles, we call them flutes. We also call them drumlins. Those are the north-south ridges that we experience every day if we ride, walk, or bike across the landscape. And one thing you'll notice, if you look at the bus routes in our region, they generally do not go east-west, so that the buses don't have to drive up and down, up and down. But when you take some of those east-west roads, you'll notice the roller coaster effect that the roads are following. And that's because of these drumlins. And those are basically, it's almost like cat nails scratching across the ground surface, forming these hills and valleys. Okay, so I'm going to switch gears here for a second, hopefully, and show you a little video. And I'm going to turn this on, and you're going to watch a couple of different things. This is starting about 20,000 years ago, and a glacier is going to advance from the top left corner of the image. And the dark blue is saltwater, the light blue is freshwater. And what this is showing us is that about 20,000 years ago, Puget Sound was not connected to the saltwater. That's because a glacier at this point had started advancing from the north and partially blocked this drainage. So I'll play it through without interruption, and then I'll play it back through and show you a couple of things and stop along the way. So one thing you'll notice is the blue, the darker blue, the saltwater, we're seeing more of it. And that's because as the glacier is advancing, it is depressing the land, which makes it look like the sea level is rising. So this is 19,000 years ago. Here comes the ice sheet, the white. It's advancing past Seattle. Notice all the water all of a sudden in the Puget Lowland. It's advancing further south, just past Tacoma, reaching Olympia. And then it starts to retreat. And the ice doesn't, what you're going to see is the ice sort of moving back, but the ice doesn't really sort of move backward like it's shown on the video, but that's just a convenient way to show it in the animation. It really just kind of starts melting and decaying at the front edge, the leading edge, and it gets thinner as it melts. And so now you see a giant lake out in front of the ice sheet again. Ice continues to retreat, and now we have connection with salt water in the Puget Lowland. The ice is continuing to retreat, so the land that had been depressed because of the weight of the ice is starting to rebound, and so we're seeing less and less of the dark blue, less and less of the salt water. And one of the things you want to start watching is down near the Tacoma area, down in here, you're going to see this big red patch. That's the Osceola mudflow from Mount Rainier about 5,600 years ago. And you'll notice the Duwamish valleys and the Puyallup valleys are starting to fill up with green, which is sediment. And that's a result of reworking of lahars, which are volcanic mudflows. And then 1,100 years ago, we had the offset in the ground surface, basically parallel to I-90 through Seattle. And that was it. This should replay. We'll see. Okay, sorry. I could mess around with it, but let's just move on. I can replay it later if you'd like to see it again, because I think it's very fascinating. So what has happened as a result of having glaciers come across this area so many times is that we're left with what we call glacially unconsolidated materials. On these, remember these drumlins, these north-south ridges that the ice scoured, and those plateaus, that even surface that we see all across the lowland. That's all been glacially overridden. And the ice in the Kirkland area, when it was last here, was 6 times the height of a Space Needle. So we're looking at 3,000 plus feet thick of ice in the area. So you can imagine having that weight of ice on the ground surface is really going to compact those underlying sediments. So one of the things that I didn't get to point out is as the ice... All right, we're having some technical challenges here. Yeah. Yeah. So, yeah, thanks. All right, so as the ice was advancing from the north, when it gets to this position here, it basically blocks the Strait of Juan de Fuca, and the Puget Lowland becomes a giant bathtub. So prior to that glaciation, Puget Sound, we think, existed similar to it does today, and it drained out to the north. So as soon as you put an ice dam across here and a big glacier behind here, you've created this giant bathtub. And that giant bathtub fills up with sediment. Okay, so the sediment that extends far from the glacier's front are the clay and silt particles, the mud, and that accumulates in this giant lake. As the ice continues to advance, out in front of the ice, we get an apron of something we call outwash. It's like river sand and gravel deposited all across the lowland between the Cascade foothills and the Olympic foothills. And that basically is forming a blanket of sand and gravel on top of that lake mud that was just deposited by the ice. Always when a glacier is advancing, there are streams coming off the front of the ice sheet from the melting of the advancing front. Glaciers are driven from the north, they melt in the front, and so we have this huge accumulation of sediment out in front of the ice. Once the ice overrides that lake mud and that sand and gravel, it compacts it. And then right at the bottom of the ice, we get another deposit that we call till. You've heard of the word hardpan before, right? And many of you have this in your backyards, and it's almost impossible to do any gardening, and you have to get a pickaxe to dig a hole, and then you just create these little bathtubs in your yards, which is really not fun for gardening. But that layer was deposited right at the base of the ice itself. The ice continues to override the area, the glacier, and there are streams underneath the ice carving these deep troughs of Puget Sound, Lake Washington, and Lake Sammamish. So that's where those came from. So that's all the primer you get on the geology. So now let's talk about Kirkland. We did a mapping project for Kirkland, and the basis for the mapping project and for looking at geologic hazards is the geology. We have to understand the geology so that we can then understand all those derivative products that we need to look at. And so we approached this by creating a database of existing subsurface information. So anytime there was a project that was done in the city for a new roadway, a hillside stabilization, a multi-story building, a geotechnical report was completed that was submitted to the city in order to get a permit, and we took that information and put it into a database, and that's what these squares are showing you, is where there were different projects of a geotechnical nature. Within those projects, often borings are drilled into the ground and samples are taken out of the ground, and somebody keeps track of the materials that come up out of the ground. And that's what all the dots are on this map. We have 5,500 points in the city of Kirkland where somebody either drilled into the ground and collected samples or dug a test pit with a backhoe in order to see what kind of foundations would be required based on the local conditions in that particular property. Most of the data that we have is from really shallow explorations because we have so much glacially overridden material in the area. The explorations didn't need to go very deep to get to good foundation layers. But you can also see from looking at this map, there are some areas of Kirkland where we don't have much information at all. This information is available to you over the internet through a couple of different sources, and you can look up information like, as we have displayed here, why was this project done? And I'm looking at this one here. When it was done, who did the work, and the location, etc. So there's a lot of information available to you. You can also look at the individual points where we have subsurface information. This one happens to be a monitoring well where somebody put a piece of pipe in the ground to determine how deep the groundwater is, and they drilled 81.4 feet deep. And this was for the Kirkland project. Sorry, I forgot the name of that one, but you know, the big project in downtown Kirkland. Thank you. So anyway, this information exists for all the points that we were able to gather for the Kirkland area. In addition to just this sort of metadata, like when was it done, how deep did they drill, that sort of thing, we also put into the database all the different layer descriptions that were provided on the boring logs or trench logs. And then we use that information to create a geologic map. So in addition to the database, we went out walking the gullies here in Kirkland. And I believe this is Maddie over here. You can just barely tell who this is. But if you've walked any of the gullies in Kirkland, you know there's not a lot to see other than vegetation, right? So we had to use machetes quite a bit. And in fact, we preferred to do the work in the wintertime, like now, when the leaves are down and the blackberries aren't so impenetrable, and the nettles, you can knock them down just by kicking. So, but we did walk nearly every gully in the region. The other thing we did was drove the city streets looking for Sani cans. So Sani cans told us when there was some kind of construction project at a property. Sometimes they were interior projects, but most of the time they were things like new utility lines, new sewer lines, new additions, new construction, and that gave us an opportunity to look into the ground below the topsoil, right? And from all of that exploration, we created something called this geologic map. And these colors tell us the geologic layers that are present beneath the topsoil. So depending on where you are in the city of Kirkland, the topsoil could be from a few inches to almost 3 feet thick in places. And then oftentimes fill has been placed on property to make it more stable or to give more building platform. So we're looking at the geologic materials underneath the topsoil and the fill. And these are layers like that till deposited at the base of the ice, that outwash deposited out in front of the glacier, that mud that accumulated in the lake ahead of the glacier. And that's what these different colors are showing us. So just because we like to brag about this, on the top is the map that we created, and on the bottom is the map that existed for the north half of Kirkland when we started the project. And it wasn't even a digital product. It was a paper map, great work for the time when it was done, but we digitized it and colored it and draped it on a base so you could see it in 3D. And then you can compare the two maps. And hopefully you can see that the map on top has a lot more detail in it than the map on bottom. Some of our findings are we have more geologic units that we were able to define. You'll notice less purple on the upper map than on the lower map, and the purple is where we expect to find till present. And that's important because till, because it's so compact and it actually sort of looks like cement, I'll show you a picture in a minute, it's not very permeable. And it's important to know where those impermeable layers are across the landscape. We found more silt and sand up at the ground surface, more peat areas. We were able to find some old units from older glaciations, which is very interesting from the geologic history standpoint. And we were able to look underneath areas where large amounts of fill had been placed for things like high schools and sports fields. So on this set of pictures, in the top right, you can see what till looks like. It really does look like concrete. There's gravel floating in this silty sand matrix. And it's really hard to dig, and Justin Brooks is standing in this pit here. He should have his hard hat on, but he doesn't. But you can see how well the sides of this pit stand open because it's so compact, it's so dense. However, if you were to fill that pit up with water or try to do earthwork in till in the wintertime, it just turns to mud. It falls apart. So good in the summer, not so easy in the winter. The map on the left highlights the purple areas, which is where we see till near the surface. It's mostly on the upper parts of the hillsides. And here's some exposed in the bottom of Totem Creek. And I mentioned this outwash that gets deposited out in front of the ice sheet by those rivers coming off the front of the ice that basically blanketed the whole of the Puget Lowland. That's highlighted on the map here in the blue colors. So it's under the till, peeking out from underneath the till. And in some places, in some gullies, if there had been recent landsliding, we were able to see the outwash, as you can, where Justin is standing here is a good example. Okay, so this is important. Underneath the outwash is, in many places, that silt and clay mud that was deposited out in the Puget Lowland as the ice was advancing. That got compacted and turned into a really hard layer. So that set us up with this package of, or the sequence of till over sandy outwash over fine-grained stuff, silt and clay. And that contact between the sandy outwash and those lake deposits is one of the baddest actors with respect to landslides in our area, in all of the Puget Lowland. And this image shows where some of those are distributed, and also shows you some pictures of what this material looks like out in the field. Interesting from a geologic history standpoint are older glacial deposits, and something that we call interglacial deposits. So we are in what we call interglacial or non-glacial time now, and this kind of climate existed multiple times in the last 2.5 million years. And we can see evidence of climates like today in the past record by looking at deposits across Kirkland. So that's kind of science-y, actually, but it's important because where those layers exist, they can exert an incredible amount of control on groundwater flow paths, for example, as well also as landslides. Okay, a really interesting story about the Kirkland geology is what happened to Lake Washington and what we can see on the landscape in Kirkland. So the lighter colors, highlighted in red, are the highest elevation, and the darker colors are lower elevation. And each different color represents a former higher elevation shoreline of Lake Washington. So if you recall from the video that I showed, when the glacier was receding, there was a giant lake out in the Puget Lowland south of the ice front. And that meant high elevation lake. And once that giant lake started dropping in elevation, Lake Washington was isolated, but it used to be at a much higher elevation, and it's been dropping and dropping and dropping. And that's what this image is showing us. And in fact, if we look at the surface of Kirkland from an angle, from a low angle here, we can see former channels. As Lake Washington lowered and lowered, we see different channels that opened up to drain water. Okay, and then most recently, many of you know that Lake Washington was lowered about 9 feet in 1916 when the Ship Canal was opened up over in Seattle. And all around the shoreline of Kirkland, and here it's highlighted by purple, we have former Lake Washington deposits. And this is an image here with this log in it from downtown Kirkland that we took this summer when they were doing a construction project. But this is old Lake Washington deposits with logs in it. And it's really smelly, it's full of organic material. It was really fascinating to see this. But you can find this kind of material all around the perimeter of Lake Washington. Okay, so that's kind of what we call the stratigraphy, the layers that are present. So what about the hazards, and how do those layers impact our hazards? I mentioned that we have this till over this sandy outwash over those old lake deposits. And at the contact between the outwash and the lake deposits, we see a lot of water coming out of the hillsides in the form of springs. And that's what this image is depicting for us. So that sets up one landslide scenario. The other one that we see in this area is something called shallow landslides. And that's where the loose material on the slope gets saturated with rain from all the heavy rain. And it's like the skin, that upper layer basically just slides down the face of the slope. And so that's what we're picturing here. And one of the things that you can do, if you're interested, is to go on to websites and look at the landslide forecast model. So once we get a certain amount of rain and a certain volume of rain over a short duration, we approach something called a rain threshold for landslides, wherein if we get more rain, we're surely to see landslides. And that's what these websites are, and I'm sure Heather has information to help you connect to that as well. So in addition to those shallow landslides, we also have deep landslides. And these are depicting those deep landslides. And there are also deep landslides here in the Kirkland area, as well as the shallow landslides. The shallow landslides we see every winter. We don't know where they're going to happen, but they definitely follow the heavy rain. The deep landslides we also tend to see in the wintertime. They're definitely not as frequent as the shallow mudslides. So where are our landslide hazards here in Kirkland? This happens to be an image on your right from Champagne Point, and you can see the cracks in the road because the road is starting to slump down toward Lake Washington. And that's what those cracks are showing you in the road. I've also shown you an image on the left, which is colored by elevation. And I want to point out a couple of landslide features on this image. This is from LiDAR again. So the circle is showing this sort of bite mark into the edge of the valley. So that's the edge of a deep-seated landslide. And the arrow is pointing to a really sharp edge, which we call a scarp, where landslides have occurred in the past. So where there are steep hillsides within the city, there is more of a risk for seeing landslides. So we put together a landslide inventory, and we did that by seeing the hillsides out in the field. We also looked at all that boring data that we compiled, and we also talked with city staff, and we also solicited information from the public. Where are the landslides? And what does that tell us about where else might we see landslides? From that information, we do something called create a susceptibility model, and that's what you're looking at here. So these are areas that have the right kind of geology, they have the potential for springs, they have a steep slope, and therefore they are at greater risk of landsliding than elsewhere. Now there's a lot of red on here, so that's not to say every place you see red there's going to be a landslide. It's just showing you where there's a susceptibility for landslides. Again, another image, the top one showing where we were able to document that landslides had occurred in the past. And the lower map is the susceptibility. So the red on that map shows us we know there was a landslide here in the past. Chances are that there could be another one here in the same location in the future. The yellow is a buffer around those known landslide areas. And those are maps that we have up and we can look at in a little bit when we're done with the presentation. So I wanted you to kind of put all of this into perspective, because these maps can be pretty shocking, right? That show a lot of area susceptible to landslides. But it's not new information. On the left is the former landslide hazard map for the city of Kirkland. And you'll notice that the same areas are highlighted pretty much on both maps. It's just the new modeling techniques allow us to be a little more precise with our locations. Okay, we also put together a database that shows where springs are located, and that's the squiggles, like this. And then we also were able to document the depth to groundwater in a number of those borings that were drilled and trenches that were excavated. And that's what this map shows. That information can become really helpful when somebody is trying to do some new development in an area and they need to know where's the water. So this information is available to help evaluate depth to groundwater. From that and the geology, we can create something called an infiltration potential map, which at a glance tells us where the sandy areas are and where the areas are that aren't going to allow infiltration of groundwater readily into, or of water, surface water readily into the ground. Okay, let's get back to seismic hazards. So we talked about the fact that we are in an active tectonic zone and there are several faults in the area. And this map is showing us These dashed lines, which are all strands of the southern Whidbey Island Fault, or inferred strands of that southern Whidbey Island Fault zone. These have not been documented as active, and active to a geologist means that this fault moved in the last 10,000 years. So these are just inferred areas where there could be a fault beneath the ground surface. And that's the southern Whidbey Island Fault zone and the Seattle Fault zone, just for reference. So we can zoom in to the Kirkland area. And these maps, by the way, that I'm showing now are from the Washington Geological Survey. They keep a database, they keep it updated. When someone learns about a new fault, it goes up on the website. So one of the things you'll notice is Kirkland is right here, right in here, and there are some strands that look like they're headed right toward Kirkland. We definitely looked for any evidence of what we would consider active faults in the area. We didn't see any evidence, but that doesn't mean that a fault isn't present. That didn't sound right. Anyway, the bottom line is we did not map any strands of the fault through the city of Kirkland. However, what's important is if there were to be movement along this fault, then the whole area is going to shake very hard. So this is something called a scenario that was put together by the Washington Geological Survey. And they say, what if there were an earthquake along one of the strands in the southern Whidbey Island Fault zone? How hard is the ground going to shake? That's what this document looks at. And the Kirkland area is definitely in the red portion, which says the intensity is going to be high here. Okay? One of the impacts from earthquake shaking is something called liquefaction, where the ground basically behaves more like liquid and it loses its strength. And this map shows us where the ground is most susceptible to liquefaction because of a shallow water table and sandy deposits that were not glacially overridden. So for those deposits that accumulated after the glacier left the area, they aren't as strong as the deposits that the glacier overrode and compacted with its 3,000 feet of ice. And as you might expect, the areas that are most likely to liquefy are in the valley bottoms. Some of the less common geologic hazards that might be experienced in the area are ashfall from volcanic eruptions, tsunamis in Lake Washington, as well as seiches in Lake Washington, and settlement from peat in different peat areas. And the only documented evidence of any kind of ground failure related to the Nisqually earthquake in the Kirkland area was along Lake Washington, where a slide occurred offshore that caused a little bit of loss of beachfront. But otherwise, we weren't able to find any recording of ground failures from the Nisqually earthquake. Okay, so let me wrap it up. We put together a whole lot of data to create new maps for the city of Kirkland and residents here. From this, we were able to recognize multiple geologic hazards, nothing new, nothing that wasn't expected. One of the things that you need to keep in mind as residents is, what's the probability that something is going to happen? What is the actual risk? These things will happen, but we can't tell you when and where, unfortunately. The products that we put together are digital and will be available online. We use something called Best Available Science, that's what the BAS is, and also some advanced techniques for trying to compile all of this information. And as I mentioned, the city of Kirkland is way out front putting this together. So you're fortunate to live in this area. I already mentioned everything will be online. From what we can see, these new products are significant improvements over what was previously available. We feel confident about what's in our maps, but there are definitely some data gaps out there. So there's some room for improvement down the line. I want to acknowledge the rest of the team at the UW. The folks here at the City of Kirkland were amazing to work with, just very proactive, very friendly, easy to work with. And also, everything we put together was peer reviewed by folks over at AESI. David mentioned them earlier. So they're geologists, they know how to look at this information, they use this kind of information on a daily basis, and they spent time reviewing what we put together to ensure the quality of what we did. And so with that, we can entertain some questions.
So I guess the best way to do this is if we could form a line along the side here and people could line up and ask some questions. We want to get these questions recorded. I was mentioned earlier that we're videoing this, and in order for us to get the value of your questions and then share that information, we'd like to have you come right up to the mic right here and ask your questions, please. And we'll do our best to answer them.
Hi, I heard that there was some potential future work in this area. I was wondering, like, what kind of future work could there be, and like, what benefit is there to the city for doing that future work?
Future work related
On the
to...
last slide, like you said, like, you can there's more things that could be done, or like future mapping that could be done.
Okay.
Like what would that be, and like what value is there to doing that future work?
Right. So if you notice that there were some data gaps on the maps where we didn't have any information from the subsurface. And when we don't have information, we have to use our geologic intuition to infer what the geologic materials are in areas where we don't have that downhole information. So down the road, with additional development, additional permit applications that contain geotechnical data, down the road, 10 years down the road or something like that, then we can look at what has become available and see if that helps us update the areas where we don't have any information. The other thing I can see happening is because this area is being actively evaluated for seismic hazards, I can see down the road that there may be new information related to the South Whidbey Island Fault Zone, for example.
Kathy, in your presentation, you mentioned that probability is a significant element in evaluating all of this data, and I noticed on many of the maps that they're categorized low, medium, high. Can you provide us any context for what that means, low, medium, high, or is there other data that'll be available online to help us understand what those stratifications mean?
That's a great question. So for example, if we look at the liquefaction potential map, the one just over here to my left, there are three colors, green, yellow, and rose, I guess, for lack of a better word. And the rose or red is the high potential for liquefaction. That means all of the conditions are present that for liquefaction to occur if we get an earthquake sufficiently strong enough to shake the ground hard enough to cause liquefaction. In the areas that are green, that are considered low, that means we don't expect to see any landslide capable of causing liquefaction in those lands that are colored green, because the ground is so glacially overconsolidated. We don't expect to see that deformation. And then in the yellow areas, it means that some of these areas could experience liquefaction. There's a moderate risk that it could, but it's not a high risk because it's not clear cut that this area could experience liquefaction. Does that help?
So I came in late, and I might have missed this spiel, but like as a homeowner, how should I be thinking about these maps in terms of like where I land on this, and like should I think, oh, I should go get earthquake insurance or landslide insurance, or should I start like retrofitting my home? Like I saw some materials being put out over there. Thank you very much, but what any kind of takeaways should I take as a property owner and homeowner? Question mark.
We might want to have several of us answer that question. But from my standpoint, as a geologist and a homeowner, you would want to find out where you live with respect to the different hazards that had been depicted on the map. And regardless of where you land in those zones, you should get your earthquake kit ready and prepared, right? Because regardless of where you live, if there's an earthquake, there could be a significant amount of shaking, and you should get your homes retrofit. I mean, those are just definitely, you need to do these things. If you happen to fall within a landslide hazard zone, then there's some additional things that you should be watching for. And Heather has some great information to share with you about the kinds of things you should be watching for, but they include things like watching for doors to not open or close very easily, indicating that there's some sort of movement going on in your house. If you live near a slope, you should periodically, especially in the wintertime, walk out to the edge and look for any cracks that might be opening up near the edge. You should be doing things like not allowing your gutter downspouts to drain onto that slope, not throwing things over the edge like grass clippings and knocking down trees, etc. So there's many things like that that you want to be thinking about if you live in those hazard zones, a landslide hazard zone. And I would also encourage you, if you find yourself at the base of a steep slope or on a slope or right at the edge of a slope, to be monitoring the landslide forecast models as well. The National Weather Service in the area now also carries information about what that risk of landsliding is, or if we're within a time period where we could see more landslides. So what else would you add to that?
I would add, from a planning standpoint, we've got these maps. They are going to be uploaded soon after we get our disclosures and clean them up a little bit so you can see them up close. Those are the basis for the code amendment process that I don't know if you heard about that we're going through right now. That's happening, and it's helping inform that process. But I don't want to give folks the impression that if you are living in a geologically hazardous area, that somehow we're going to know exactly the conditions that you're in. And what we hope to do is to have some resources. And I know that Heather Kelly and I from the she's Office of Emergency Management, they're going to have resources on their website, checklists, kind of kits, and we're going to cross-link to the planning department's website too, so we can cross-share information. So yeah. Oh.
Hi. My name's Larry Kilbride. I live at 13125 Northeast 128th Place in Kirkland. There's parts of this that's way above what I understand, because of what you do. But I see green, yellow, and red, theoretically, in the charts. And green meaning it kind of looks okay. Yellow meaning, it might be a little dangerous. And pink or red or rose is being pretty dangerous. That in itself makes it pretty clear to me. But when we talk about liquefaction and movement of the earth, it seems to me like the yellow should be yellow with an underlay of orange. Because if something happens on the pink, that yellow is not going to be yellow anymore. I just don't understand that.
That's a good question. So on the land, one of the things this is addressed really well, I think, is on the landslide susceptibility map. So where we have red, meaning, higher susceptibility, adjacent to that, we have something called a buffer, which is medium. And then beyond that is low. So in a landslide hazard zone, I think that's an appropriate thing to have, these buffer areas. But on a map like this, the places where we might have orange would be just immediately adjacent to the red. So it'd be a thinner area than all of the yellow, for example. Does that
I just
answer?
thought I'd mention it,
Yeah.
because if my hillside falls down, I go away, but also the person below me goes away.
Below you goes away, right. And I hope that we've captured that on those landslide hazard maps. That was the intention. Yeah.
Thank you.
I wanted to add one thing to one of the earlier questions, our answers to one of the earlier questions. If you live in one of those hazard zones and you're really worried about your property for any reason, I know this sounds self-serving, but hire a geologist to come out and take a look at your property for you to help with peace of mind, or to tell you the things that you can do to help stabilize your property. A licensed geologist. Thank you.
I don't need to do that, you've already done it.
I'd like to ask a question to further understand liquefaction. On the one slide you had the till, the outwash, and the mud clay layer. And it showed the water percolating down and stopping at the mud clay layer. So does the liquefaction take place in the outwash zone or in the outwash and the mud clay layer? Because by the slide it looked like the bottom layer was very dense, of course.
Okay, good question. And so liquefaction isn't generally going to happen in deposits that are compact, right? Because they're dense already, and the earthquake waves aren't going to sort of disaggregate that material. Where we see it happening is in material that wasn't glacially overridden. It's sandy, and so there's water in the pore spaces and the spaces between the sand grains. And when the earthquake energy hits that water, it drives the water out of those spaces between the grains, and the deposit really can then turn into a liquid. And so the criteria are that it's loose to start with, not glacially overridden, that it's underwater, and in many cases there's a cap over the top to help maintain the buildup of pressure in the water in that sand.
So that is the outwash zone then?
It could be, it wouldn't be the outwash in the hillsides because that's been glacially overridden. The ice overrode it. But it would be the sandy material in the river valleys, in our creek valleys.
Thank you.
Yeah.
So this body of work was primarily for the city's planning and zoning purposes. Does this work have any academic research value to the UW at all, or is it purely just for the city's use?
Yes, it has academic value in that every time we create these landslide models, we learn more about how the materials in our region behave. And the more of that we can get, the more we can learn. So it contributes to, I guess, the greater geologic good, if you would, right? But this was specifically done for the city, and this work would not have been done if the city had not needed to update their geologically hazardous maps.
This question is probably more for the city. What's the city's intent to do with this? I've heard mention of amendments to the code, and I'm curious what that's looking like. This seems like information that would inform that, but I'm wondering where that would go.
Well, we're just starting the process. We're kicking off the code amendment process with this presentation. The maps that you're seeing displayed, as soon as we can get them online, we're going to be using them. We're not waiting to go through the code amendment process to use these more highly refined maps. And, we have Associated Earth Science, who are local geotechs. They're going to be working with us using best available science to look at our current codes, how they're written, to see where the gaps are, see where we can get better using, more advanced science, and I'm going to be helping take the city through that and the public through that process over the next 3 or 4 months, so we can, amend our codes, presumably to use or kind of geotech reports and these maps to determine on a site-by-site basis how a property should be developed or shouldn't be developed or partially developed. It's developing. If you come to the first study session, you'll kind of see some recommendations coming from our subject matter experts, and you can participate in the process through public comment, and there will be a public hearing on this too. So you'll be able to kind of follow that kind of process.
I'm just curious where the current thought's going, and I think that what you said is that the city could potentially determine that certain properties can be developed differently than they are now. Is that right?
I'd say that's fairly accurate. And again, we're going to rely on geotechnical reports, site-specific geotechnical reports, and it'll be interesting to see how it plays out. We have the option written into our code right now to require peer review of geotechnical reports. Who knows if that? Who knows if that will be the requirement always or not? I don't know. We'll have to see how that plays out. But definitely there are some gaps in the code, and it will be amended, I think, to become much better. And the public in general will be aware by these maps of areas where there's more risk.
But what do you mean by amended? What's an illustration? And Jeremy looks like he keeps getting ready to push the microphone button, but not yet. I don't know if I am either, but I'm curious.
We're required under the state's Growth Management Act every 8 years to update our critical areas regulations. We haven't done that for geotech because nothing's happened. The science really hasn't advanced that much since the initial maps and our initial code were drafted back in the early 1990s. But with the availability of LiDAR in the University of Washington, we know a lot more about what Kirkland subsurface conditions are. The way the code's structured right now, is that if you're in a mapped area or near a mapped area, that tells us that before we issue permits on that property, we need to see a geotech report, essentially that says what you build there is going to stay there and it's not going to be dangerous to you or to your neighbors. So fundamentally, we're still going to be regulating it the same. We now have more refined mapping areas. Right. We're in a post-OSO thinking a lot more about buffers, like so how far back from the top of slope or from the toe of slope should we be concerned about. So those are some of the things we'll probably be looking at. But I don't know that we think that the code requirements will change substantively from what we have right now. It's the map sort of kind of as a red flag that we need more information from a safety standpoint before somebody gets out there and starts disturbing these areas.
Well, to repeat what you said, which is my understanding of it as well, which is if it's in an area where there's a map that shows some geological hazard, what the city says to someone who wants to obtain a permit is, hey, go get a geotech licensed one and go get a geotech report and tell us what needs to be done from an engineering standpoint to take into consideration the soil. And am I saying that accurately, do you think? But what the city doesn't say yet, as far as I know, and this is where I'm going with this. The city doesn't say, oh, well, you're in a red area there. Don't even bother to go get the geotech report. You can't do anything with that property. I don't think they say that. Do you envision that happening as a result of this work?
Not necessarily. We've started to look at how other jurisdictions manage these areas. And there's some jurisdictions who say they start with the premise you can't build there, but you can go get a geotech report and prove us wrong that
Right.
it is safe to build there. What Kirkland's code has historically said is you can build there if your geotech says it's okay. So it just kind of flips the process a little bit differently, by and large with the same result, because we do have geotech reports that come in under Kirkland's code as written that say, you know what, don't build there.
Well, and I think that there's another piece of it, Jeremy, which is you can build there if you want to spend a ton of money and go down deep enough and put in enough stuff to ensure stability, but people choose not to do that.
Well, there's that, and there's also the scope. If there are areas, if you would have to mitigate areas outside of property that you control, it may just be too big
Right.
an issue for you to really manage.
Right. I'm just wondering if people's property that they, I'm just using red because it's quite visible. Well, I know I'm in a red area, but I've known that for a long time, but now is the city possibly going to say, well, you're in a red area, but you actually can't do anything with it?
No. I mean, I know your red area, and no.
I'm actually kind of a pink area, but.
There are some red areas when you look at some of the valleys and ravines in Finn Hill, for example.
Right.
You probably wouldn't get a geotech
Right.
report.
Finn Hill is redder than the area
Yeah,
right.
it's very red. So that's
Right.
why that always comes to mind. But you're probably not going to get a geotech report who would say it would be okay.
Right. Right. Okay, thank you very much.
Sorry.
Before that last question, oh, the gentleman who couldn't hear is out. Never mind.
Okay.
Go ahead.
My question kind of falls along his, because I would think that if you have a piece of property that's got any kind of slope on it at all, you're going to say that landslide hazard is greater than 0, statistically speaking. It may be, infinitesimally small, but it's not 0. So then you're going to get into this high, medium, low, and so you're not going to get a geotechnical engineer to say the risk of landsliding is 75%. You're not going to be able to establish that numerical threshold. So that kind of leads into, okay, what is going to be acceptable and not acceptable? And because I'm actually a geotechnical engineer, I'm having problems with the Snohomish County because they don't really define landslide. And in our reports, if there's any kind of slope on a piece of property, we say there's always a potential for landslide. And the county is now interpreting that as, wow, it's a landslide hazard, therefore you have to have a notice on the title. And it's not, I don't think it's what they really intended. And so I'll give you Snohomish County as an example not to follow, or see how poorly their definitions are, and they're reading it so literally that any slope any property that's got slope over 33% basically falls into landslide hazard zones, and they have a notice on the title, and that's just, the whole county's going to be red with that. So, well, Kathy answered my question about landslide hazard is not 0, and like I said, we're stuck in the position of saying, yeah, it's safe, but under what circumstances? It's safe for anything but the 100-year earthquake or the big one, that type of thing, because we don't have the crystal ball.
I have 3 questions. The first one is, does liquefaction intensify with the earthquake magnitude?
Yeah, so there's a couple of things that impact the intensity of liquefaction, and that's going to be how long the shaking lasts, as well as how strong the shaking is.
So the damage will then increase with the intensity of liquefaction?
Yes.
Okay. The second question, on the landslide map, the cause of landslides, is it from water and or seismic events? And how do you look at those?
Okay, so the maps do not show the hazard or susceptibility due to seismic, to earthquake shaking. Okay, so they don't show us that, but they do show us where the ground is susceptible to sliding, meaning the conditions exist, being we have a steeper slope, we have the right kinds of geology, and the potential for groundwater in the slope. And so the potential exists if the trigger occurs to cause the sliding. So increase in rainfall, for example, or someone cutting the toe of a slope, destabilizing a slope, or someone adding load to the top of a slope. So those are the kinds of triggers that could cause landsliding in the areas that are susceptible.
Okay.
Does that make sense?
Yes, I was
Okay.
just trying to figure out if I'm in a red zone, what is my risk during an earthquake when it's dry, that type of thing. So.
Yeah, that is a hard thing to say because it depends on the size of the earthquake and how much shaking, how long the shaking lasts. And so that becomes a really complicated thing to actually figure out. There was a study recently done by someone at the University of Washington who looked at seismically induced landslides in Seattle, assuming that there was a very large earthquake in the wintertime, and the results were really scary. It's a very complicated set of things that you have to juggle to try to get an answer to that.
Thank you. And then my last question is the Department OEM. Do you take into account the red zones and how you're going to plan around that? Because those areas will probably be cut off.
We use all different types of geological data and information as to our advanced planning for all hazards. So yes, it is of interest. Will it change how we plan? Potentially. We are using it with our first responders so that they can do some alternate planning for routing around and things like that, because they're really the first ones out there in the approach. And we may end up using it for where we set up community response teams or points of distribution, knowing that there's a higher risk of limited access points.
Thank you.
I have a question about the LiDAR, the penetration into different depths. And in the beginning you said you had gathered a lot of data from core drills and individuals reporting on their situation. I know in my yard the condition of the soil, maybe 3 feet. But how do I know that I don't have a problem underneath that? How can I use this data to fine-tune my knowledge on that?
Oh, good question. So one of the things that you'll be able to do, and we can do this before you leave tonight as well, is just look at your neighborhood, and you can talk with me or any of the other folks that are here with us that helped put the maps together. But what you'll be able to do online is zoom into your neighborhood, and you'll be able to see what color your neighborhood is on the geologic map, and you'll be able to click on that, and it'll give you information about what the geologic material is expected to be, in your neighborhood, in the area around your property. And from that, then you'd have to have some additional help in interpreting what that means to you. But there will be some information already available when you click on it, when you zoom in.
Okay, thank you.
Okay.
Sorry I couldn't be here earlier, so I might have missed it, but I live on a property that's off of Juanita Drive, and I'm not sure. I've wanted to do something about planting and reinforcing. I share a driveway with 3 people, and I'm just not quite sure how to go about it, because part of it is, abutting the road, and part of it is our property. And so I don't know if there's anyone at the city of Kirkland who I would talk to about doing that, because I feel like it would, anything I would do would, like I said, be abutting the road. So it would have to involve, I think, the city of Kirkland. And I've kind of called them out and said, it looks like, we're getting eroding sediment to the driveway. We have to kind of push it back. The rain is, and they kind of said, well, the driveway was sloping the other way. So I'm not quite sure who or what to do. Like, I'm feeling like something needs to be done, but is there someone that I would talk to about that? Or what, in that situation where you're abutting the road and it's in an area where you probably should be doing something about it, what do you do next?
David, maybe you can translate for me, our Public Works Department, including our roads folks.
Your mic isn't working.
The Public Works Department, road folks, and maintenance of surface water.
Yeah, I talked to them about that, and they came out and they said the road was sloping the other way, anyways. And so, but part of me was like, well, if I work on the other side of the road, like, I'm not quite sure what to do with the part that's like abutting. We need to drive. So that's kind of what I did already. So is there anybody else I could talk to more about that? Or is, yeah.
The Public Works Department kind of owns
Okay.
the roads, so to speak. But on your side of the property, we were talking earlier about resources and learning about what you can do on your property. There are checklists. Their Office of Emergency Management is going to have stuff, but also site-specific stuff. It usually comes down to having a licensed geologist look at the situation as well. There may be some things that you can do on your property, and there may be some things that they might need to talk to the city about.
Okay.
But yeah, that's.
Okay. Another thing is, you talk about planting like natural plants and things to reinforce the hillsides. Is there any other resources, or are you planning on having any resources for that as well? That's just a suggestion. I know King County has some, but.
Yeah, we can certainly reach out to our parks and our public works and see if there's some resources they can help us put together, or include that in one of our community sessions where maybe there's a table and they can talk about those types of efforts. So we'll add that to the list to talk with them.
Okay. So who is the person I should speak to at the park, or the Works Department? Is there, if I could just
Public
look it up
Works
online?
Department.
Public Works.
You said roads or maintenance. Is that?
Yeah, I can give you a card.
Okay.
after that.
Okay.
Or if I just look up Public Works.
Yeah, they have a help request line.
Okay.
They can hook you up with the right person.
Okay, thanks.
I was wondering if I think you briefly mentioned there had been tsunamis in Lake Washington. I was wondering if you could maybe expand a little bit about that for some of the people closer to the water.
Okay, yeah, it's a very important topic. So we know when the Seattle earthquake moved 1,100 years ago, that a wave was generated in Lake Washington, and that wave, just like in Puget Sound, pushed north and also then oscillated and went to the south. And so down in, what's the name of that area? The south end of the lake, there's a park down there, and there's some evidence of some tsunami deposits in the park down at the south end of the lake, and also of Lake Sammamish. So we don't know very much about tsunamis in Lake Washington. And the other type of wave I mentioned was a seiche. So a seiche is kind of this oscillatory wave that can be created in enclosed bodies of water. And that can be generated as a result of shaking. So the Denali earthquake in Alaska created an oscillatory wave in Lake Union and in Lake Washington that rocked some houseboats. So we don't know a lot about the potential for or the size of tsunamis that we could see in Lake Washington. In the past, there's evidence, I think, of something on the order of like a run-up of 6 feet or so onto the shore, so not very big. But the requests have been made to NOAA and the tsunami modelers at the University of Washington to really try to start looking at this and providing some more information. there's not a lot of information available other than the fact that we know it's possible, it's happened in the past, it's likely to happen in the future if there's an earthquake, fault movement on the Seattle Fault Zone where it crosses the lake. So unfortunately, the science just isn't there yet. So, yeah.
Excuse me. Sorry, I was listening and you were talking about your sources of information. Are you drilling strictly from test pits or drill holes? Is that
So
right?
the information we collected were borings that were already drilled and test pits that had already been excavated, and where somebody kept a record of what was encountered.
Okay, I think you're missing a major section, and the reason I ask is we live on Finn Hill. If you know where that is, it's local knowledge anyway. It was logged about 1900. I've lived there for about 30 years. Puget Sound Energy has been through a couple of times because all of our services are underground. They're breaking cables because the hill is moving slightly. North Shore Utilities, who provides our water services, are through because they're breaking water lines and breaking water mains. There's a big patch of red up there because, or should be, that I don't think you've captured. I'm just throwing that out to you that you may be missing a very valuable source of information. And this, I've lived there before it was part of Kirkland. It was part of King County. So I don't know if there's been a loss of data with the handoff between the county and the city, or it was just missed.
You know, can you see me afterwards and show me the area specifically that you're looking at on Finn Hill?
Pick the east side above Safeway.
Okay.
That's the easiest way to look at it.
Okay.
That whole hillside has the same issues. If you go into the streets, you will see where Puget Sound Energy has had to recut, and they have had to put strain relief in and rerun the cabling.
Yeah.
Talk to North Shore Utilities. There's a big hole. I live on a cul-de-sac. There was a big hole where a water line went up, these kinds of things. They are through routinely running their searches down the all the drain lines and the sewer lines because they're not saying it, but they're looking for breakages.
Right.
And they are routinely on that hill doing something, and it's not just the where I live, it's multiple streets.
Thank you for that. There definitely were some challenges in trying to find information out there because of the change in, what do you call it? Not ownership, but jurisdiction. Thank you.
Yes, it was. We went from King County
Yes.
to
Yes.
Kirkland.
And it was hard to find information. So thank you for that.
Well, I've been there for 30 years, so.
You know, yeah.
Yes, and we have all underground services, so it does become a condition.
Absolutely. Thank you.
Peace for me. Thank you.
Comment about tsunami. I think I saw on one of your slides towards the end that in 1949 there was an 8-foot tsunami. Did I see that?
Yes. So in 1949, one of the things I didn't mention is that these deep earthquakes, like Nisqually, happen every 30 to 50 years. And there was one in 1949, one in 1965, one in 2001. And in 1949, there was a landslide south of Tacoma, and that landslide occurred 2 days after the earthquake, so we all think it was probably related. But that landslide entering into the Tacoma Narrows caused a tsunami wave that then went across the Narrows into Gig Harbor, and it was a wave about 8 feet high. It knocked over boats. It was pretty significant, yes.
But not up here in Kirkland.
But not up here.
Okay.
Yeah.
So the other question has to do with liquefaction. You mentioned that the probability or the likelihood is a function of the magnitude as well as the duration of movement of an earthquake. Can you put boundaries or ranges around each of those factors, those two factors? So how small an earthquake might it be if it lasted a long time. I mean, that would be one set of conditions.
So the answer to that is yes and no. So the Nisqually earthquake was a 6.8, and the reason the answer is no is because it's not there's not a straightforward answer. So the Nisqually earthquake was a magnitude 6.8. It was a deep earthquake. We didn't see any liquefaction here. We saw it in Seattle, very little in Tacoma, and a lot in Olympia, right? And so depending on the direction that those energy waves travel, there'll be a difference in where liquefaction occurs, and it doesn't. So it's not strictly tied to the size of the earthquake. That being said, there are some very complicated models that can be run on areas to say it's going to take this amount of shaking to cause liquefaction of this site. So that's a very complicated modeling system, modeling approach that is done on site-specific basis, but it's cost prohibitive to do it on like a citywide basis. Does that make sense?
Yes.
Yeah.
The models are available publicly or no?
Some of the models are available publicly, and the folks who do a lot of that kind of work are geotechnical engineers, and specifically those who are doing earthquake engineering. And so for big projects like the Safeco Field, the stadium, the two stadiums, for example, then site-specific liquefaction modeling is done because it's a very expensive project and there's a high risk of liquefaction, and therefore an earthquake engineer is engaged and that modeling is done. There was something else, though, that you reminded me of when you asked about the tsunamis that I mentioned. The one that had an 8-foot wave in the Tacoma Narrows. When the Seattle Fault last moved 1,100 years ago, there were some very large landslides that resulted. And the south end of Mercer Island and some areas along the shoreline of Kirkland experienced large landslides that slid into Lake Washington. And chances are, with that volume of material entering the water suddenly, there would have also been tsunamis generated from that. But again, the research isn't there yet.
Have you been able to confirm the forest on the north side of Mercer Island in the lake?
So the question was, have we been able to confirm the forest on the north side of Mercer Island in the lake? And I have seen some sonar images from that area, and it looks like there are some trees there. Yeah. Yeah.
Hi, it's me again. Thank you for scaring us. And thank you for the presentation and all the work that went into it. I appreciate that. And I just want to say thank you to the city for inviting us to the party at the beginning, not at the end. Very well done. Thank you.
I would also like to add, I know there are a few geotechnical engineers in the audience, and some of these questions have definitely been on the geotechnical engineering side. Is there anything any of you would like to clarify about what has been set up here? Okay,
Oh, sure.
doing okay.
I've been on this side before, and I think what I missed at the beginning was the state requires.
Yeah. Thank you.
The Growth Management Act, the state requires you to update your codes every 10 years, I think, using best available science. So that's really what triggered this process. And then I think maybe the other thing I wanted to point out is mapping out the geologic hazard areas is a planning tool. And so it's the first cut at where there might be a hazard. And so then if you're trying to develop that property, you should have some special studies done. You should call in the experts to find out if you actually do on that property or not. That's really what's initiating this whole process. And now we've got a lot better science. We've got the best available science now. So.
Thank you. That was well stated and very true.
Can we hear the stories from the 9.0 earthquake lady? I'm curious.
He wanted to hear your experience in Alaska. You want to come up here?
Well, I was in Anchorage near the Turnagain Arm, and the entire arm liquefied, and it was about a quarter of a mile, and many homes were lost. And there was, my father worked for the gentleman that owned the furniture company. So he had a huge house and lots of furniture. And the only thing they found after I think his house was 5,000 square feet, was a little ice chest and one set of curtains. And there was nothing else left. And there were many homes that were just lost. The earth opened up and they were swallowed. And it was very frightening. It went on for close to 7 minutes. And we took about 10 steps, and after that we could not walk. You crawled. And my father was driving, and he said that you couldn't drive once it started, but it was an incredible, and the sound, it's so loud, it's like a jet engine. That's what was very startling, because I thought it was a big wind, is really what I thought was initially. It was a wind because of the sound. So the other thing is just be prepared, because you need money, which if you don't have money, you can't get into the banks or the cash machines, and keep your gas in the car filled, your gas tank, because when they do open up the gas stations or electricity, it's meant for first responders, police, etc. So really, you have to be prepared, because we didn't have water, I think, for almost 2 weeks, and no electricity. So you really have to be prepared to take care of yourself, and you can't expect any help. So anyway, thank you.
Loss of life?
Loss of life, yes. I knew personally three people that died. Oh, sorry, I knew 3 people that died. My biology teacher and a couple of children that I babysat. The 12-year-old went in for the 2-year-old, and they never found them. So, but it wasn't.
Television set.
Yeah, it was. I think it was because of the time it occurred and the date it occurred, which was Good Friday. I think it was 5:37. Most people were on the road, and the schools were out because of Good Friday. And it was just really a lot of miracles happened, because I know a school was leveled, and an apartment building that had just been built. And it was a new way of construction where they would build the floor, then jack it up and build under it. They do it a lot at Microsoft. And the building collapsed, and all you saw was the elevator shaft. And it was like 10 stories just flattened into about maybe 3 stories. So that was very shocking. And so I don't know, just be prepared. Yeah. Yeah, I threw one of the old television sets that probably weighed 25 pounds across the room and hit the wall. So, yeah, it was just nothing. I had never experienced an earthquake prior to that, so I really didn't know what was going on. So, but And it's the aftershocks that will really drive you crazy, because the aftershocks are, they were in the 8s for weeks, and then 7s, and for a couple of months. And that was really frightening. I mean, it really drove a lot of people to the Psychiatric Institute, and they put up tents because there were so many people that were really distressed over it. So anyway, there was I know in downtown Anchorage, it liquefied and it dropped. The marquee on the theater dropped to street level. And so all those buildings were lost. But that whole area, it would be just like First Avenue here, if it just dropped about 30 feet, 40 feet. So anyway, that's my experience.
Thanks for sharing that. Hopefully we don't experience anything like that. But it also brings up a good thing about preparedness that we've been talking about, and making sure that you are prepared for even smaller things that happen: water, food, fuel, things like that. And we've got to do that, otherwise you're going to be stuck. So anyway, any last questions? We were planning on having, like Kathy mentioned, people be able to look at the maps and have people that know about how the maps are constructed and what's on them, talk about them a little bit. But is there any last questions before we do that?
Will you notify the community when you're dealing with their neighborhood? Like code amendments?
Well, we're doing citywide code amendments is what we're doing. And the planning department's going to have a webpage here up shortly. The next meeting that we're going to have with the Planning Commission is on January 11th, 2018 here. And what I'll do is, as we keep going through the process, we'll have the staff reports, we're getting the maps up there, and there'll be a listserv that you can put your email address in, and then you can get updates from us as we update the page. That's how we would communicate that. Also, our neighborhood communication or neighborhood coordinator is getting out information to the Kirkland Alliance of Neighborhoods and some of the other, and every major neighborhood. So it's not specific to a neighborhood, that it's going to encompass the whole city, what we're going to work on. Okay. So I think what we're going to do for the folks that do want to stick around, we've got maps over here. And we've got some maps over here. And then in the back, if you feel like it's a little too claustrophobic in here, you can actually go to the back there out in the lobby. And thank you for coming. And hopefully, if you have any other questions, we can try to answer them with the map sections. So thank you.